Okay, this is my presentation of about the main station based on Mars. I'm Professor Julio Rezende. This is the mission 60. Today is the December 12th, 2020. Okay, in this presentation that I am doing about the main station, all the times we are doing improvements. Okay, and I hope that you like this presentation. Okay, these are some topics about my presentation that will be discussed during this moment. And then this is the design of our entire station. In this case, we have a launch control center. The launch pad is something like 1 kilometer far from launch center. Also, the main station where I am the chief, the health facility, the greenhouse where is produced the food, the sanitation center, okay, the engineering facility, and then the last and also very important facility is the power station. Connected to the power station, we have the MOXIE technology transported in the Perseverance rover to Mars. Also, we have connected to the power station the solar farm and also the kilopower. Okay, the kilopower is a new technology uh, based in nuclear energy. Okay, and then these facilities are very important to provide energy to entire station. But in this presentation, we'll be talking about the main station. Okay, and then we have 5 dimensions in this presentation. The first presentation is the internal design. The second one is the some technologies aboard. The third is the management of the station. The fourth is the some protocols operating the station, and the fifth dimension is the some spin-offs, some possible solutions to be applied on Earth. And then it's possible to see here if you have in the main station just one model, how this model would be used. And then this was a proposition done by the architecture student Yash Rato from India. But we are proposing something bigger to accommodate all astronauts, because the main station is the place where all astronauts are sleeping and become together. But we also have some beds in the specific locations, in the specific facilities, because during the threat of a virus, the astronauts are sleeping in the specific facilities. Okay, but we are proposing a redesign of this idea because we need space to accommodate all astronauts in the main station. Then in the main station, we have some facilities that I'd like to share with you, like the control center, functions of management, communication, dormitory, training room, dining room, kitchen, gym, spa area, recreation area, research room, and also a small vertical garden with plants for meal. Okay, then these are uh, some facilities or some areas in the main station. Okay, and then something interesting that we have you like to share with you, in the main station we have some plants, and then some reasons for we have the plants aboard is the plants are important to evaluate the air quality, brings nature to space habitat. This is the presence of nature is important to psychological well-being. This means less stress and more health. Also, possibility of vegetables production, bring practicity and easiness to prepare the fresh meal. Okay, the concept pick and eat. Okay, we are the vegetables in the main stations is not in a big quantity. The in terms of the use of these kind of vegetables to prepare the meal is just a amount. like spices to be used to prepare the meal, because you know that we have the greenhouse to produce the greater part of the food. Okay. Then, as something interesting, we have very important in the main station is the control center, responsible for activities of management and communication. And then you can see some computer screens. In this computer screens, in this concept, these computer screens would be used to control many systems operating in the in the entire station. Okay. Also, if you look the here about the ships, the Apollo, Shuttle, and Dragon from SpaceX, you can see a evolution in the dashboard in the panel of the ship. Okay, then you can see a lot of specific controls during the Apollo, during the moment of 1961 to 1965, and then evolution to the shuttle, okay, the space shuttle. And now more recently we have only almost computer screens in the SpaceX capsule, and then in this computer screen it's possible to change about the information from a system to other system, and then it's something very uh, that looks like the our programs that we are using in our computer today. And then the main station is responsible to have the follow up, doing the follow up of the all activities operating the entire station. And then in the main station, okay, we have like control mainly of the activities in the greenhouse, the power station, the sanitation, the health. Okay, and then I just add this next slide to share with you today. This is the crew that will be showing for the first time the next slide. And then also in this slide you can see some aspects, some elements controlled by the main station. Okay, and then if you look here in the middle of this slide, the main station will be controlling some elements of interior. Okay, like the levels of water, levels of food, temperature, and humidity. Also, the main station will be controlling exterior uh, aspects like the evaluation of external condition. Okay. Also, this would provide guidelines to extravehicular activities and energy supply. And then also you'll be looking the weather, the temperature, the lightning, also the possibility of wind and dust storm. This also the main station will be controlling the operation of extravehicular activities of astronauts and vehicles. Also, during these moments outside of the station, the main station will be controlling levels of oxygen and energy. Okay, and then if during the if you have vehicles traveling in Mars to collect the ice to bring back, they will be looking and send message to the astronauts say, look, you have only 50% of your battery, you need to come back to the station because the vehicle will stop. And then also you are in a risk moment because your the levels of oxygen is not high. And then the main station will be bringing alerts to the astronauts during the extravehicular activities. Okay, also uh, the main station is in contact with greenhouse because it's necessary to see the air, the levels of oxygen and carbon, water demands and consumption, temperature, inner climate inside the greenhouse, also demands of energy, okay, and then also other aspects. Also, the main stations are very interested about the health dim- dimensions of the astronauts, like mental condition, heart rate, calorie consumption, level of physical activity, blood, urine, feces, uh, periodic exams, also reports and alerts. And also will be controlled the power station. and also contacting the chief of the power station. Also commenting about the power generation and its sources like kilopower. How is this the also talking with the power station chief about the consumption of energy of in the study station, and then also demand for more energy. Also the systems operation. Also, they will be the main station will be talking with the sanitation center chief about the generation of gas by the biodigester. Also, the sewage collect source of water. If the water sewage collected was from the food preparation or the source of a specific facility, the water produced, okay, able to be consumed. Also, the ice received from the extravehicular activities, the quantity and the quality. And then the main stations is contacting all facilities to be, we have a this we about have conversation about these topics, okay? And then a research room, also the dorm with a shelf, a place to the astronauts leaves his things. And also in the kitchen, we have like a vertical garden where where the cooker, the chef of cuisine, will take in the some spices to prepare the meal, okay. And then in the right is possible to see a technology called Molly. um, these are computer from the company called Molly Robotics, okay. And then these are a technology available, and then it's very interesting because if you have money, you can buy this technology for your house. Then it's very interesting because it's based in machine learning, and then the camera uh, reads the labels of the foods and understand what is written in the labels, and then this is the machines can add the elements to prepare the meal. Also, we have in the left here a person talking about how to prepare the meal, and then this he's also giving instructions to prepare the meal. And then you can imagine that this can bring a lot of agility to prepare the food in the space station. Also, the dining room we is not big. You are imagine some rotation between maybe we have 80 astronauts for each time to lunch and dinner and breakfast. And also the gym. And then these facilities are, we imagine something new. This was imagined with the participation of a Brazilian student of architecture. Her name is Mariana Guerra. Mariana Guerra. And then she imagined three facilities in a shape of hexagons, and then these hexagons would be transported inside the payload area of SpaceX, and then these three hexagons are integrated, okay. And then the name of these three facilities are the Alpha, Beta, and Gamma. And then alpha is a area to prolonged use, and is a silent sector. Is also for resting. The beta is for medium use, is a social area for leisure, and the third one is the gamma, is for scientific use and work. And then in alpha model we have bedrooms and study room. The beta In the beta model we have the kitchen and dining room and living room. The gamma model we have the training, control, and research room. Okay. And then also in the alpha model we have the bunks for the beds for the astronauts. The design is for 26 astronauts, and then this station is in the we are considering in the maximum 26 astronauts in the station. Okay. Also, We have in the alpha model 2 bathrooms and 1 study area. In the beta model, we have the kitchen, dining room, living space, and gym. And also in gamma model, we have the research room, training room, and control room. And then we are going to the second dimension of these presentations is the applied technologies. And then some applied technologies to the operator of the stations. Of the station, we need the oven, fridge, virtual reality headsets, also spa hydro message, disco lighting, communication technologies, antennas. And then we need a lot of technologies about, and also one of the models, the second model is the beta model. We need some technologies to entertainment, okay? Like disco, virtual reality, red sets, and bathtub. Some possible resources generated in situ or in Mars or transported from Earth. Almost everything will be transported from Earth. Okay. Also, part of the food will be produced in the greenhouse. Okay. And then now I'm going to the third dimension, talking about the management. Okay, in terms of the organizational structure, we are imagining 4 astronauts. One will be the commander, the second one will be the executive chief, the chef, and the general assistant. This is the 4 positions in the main station. Okay, the commander, in terms of the profile, someone with a multidisciplinary background, also someone of from management of industrial engineering, high capacity of leadership, also high personal resilience. Some duties of the commander is control of the extravehicular activities and rovers integrated to the and vehicles. Okay, integrated with engineering center. Also propose routines and operational protocols, provide guidance to avoid risk, conduct educational activities, preparations for EVAs, also coordinate daily communication routines with the space agencies like NASA, ESA, ISRO, and other space agency, if mission control. Also communication with the facilities in the station, also communication with the crew, and sometimes communication with specific individuals. Okay, and then the second position is the executive chief is engineer or someone with information technology background. And then some duties are monitor all operations, keep all facilities running, monitor routine maintenance, organize specific operations and responsible people, coordinate training, also organize specific operation and responsible people. Also, they simulate self-sustainability, each one observing self-organization, self-maintenance, self-fix, alerting others. And then the third position is the chef. This person would be a cooker, a cuisine chef, a nutritionist, a gastronomer, and then some duties are define the menu, the meals, the food logistics, perform food preparation, waste disposal, cleaning, organization. Also assess team's nutritional requirements. Also plan the availability of food. Also define the feeding shifts. And then here we have a photo from the Matrix movie. Uh, then in this photo, we have the Neo, okay, the character of Keanu Reeves, and then in this photo, Neo is aboard of the Nebuchadnezzar ship, and then he's all days he's eating the oat, okay, and then he's for him is this is very boring because all days is the same meal. And then the chef, it will be a person that needs to prepare a very delicious food, very different food from meals from each day to other day. And then also something very important is need to balance the meal. the meals and the food transported from Earth. As you can see here is the astronaut food, okay, astronauts meals, and then is are the plastic bags, and then they fill the plastic bags with hot water, and the hot water keeps contact with the food, dried food, and then this dried food expands with the water infusion. Okay, and then you need to combine the food transported from Earth and also the food produced in Mars. Okay, then you can see here these are some food produced in our analog station Habitat Marte here in Brazil. As you can see, uh, basil, pepper, and also lettuce, okay, produced in mass. And then they need to combine these two kinds of food. And then the fourth position is the assistant. The assistant is someone with background engineering or information technology technician. And then also is some duties are the emphasize the team's well-being, create interesting content to entertain the crew, food management, support the chef, coordinate the organization of the dormitory, coordinate the gym, also manage laboratory tools, and also applying the psychological service with the crew. Okay, and then about the training program, we are imagining new skills based in situations verified in Mars, also systems operation of new technologies, also positions and tests of each astronauts, also simulations. And then we saw some interesting videos in the YouTube, okay, like make things work, how manage your mental health, baroque music collection, also occupational safety, building resilience, and then also in terms of resource necessary for 1 week. Also, we need water for drink, water to prepare the food of astronauts, also the water for bath of the astronauts. Okay, and then we are considered that the astronauts is 1 kilo of food by each day. Part of the food will be we have the water added. Okay, and then some guidelines to provide to other facilities are related to daily routines, health occupation, health, environment, and safety guidelines, how to maintain plants in specific space habitats, provide harmony and collaboration, make astronauts comfortable about to be in space, stimulate cooperation, innovation, creativity, co-creation, emphasize the well-being, stimulate the self-sustainability. And then now I'm going to the fourth dimension of this presentation is related to protocols. The protocols, we are imagining some specific protocols in these stations, in this facility. We need protocols for harmony and relationship and collaboration, also protocols to deal with stress and relationship, protocols to organize the room for plant maintenance, food production, okay? And then we are considering some protocols of safety related to hygiene protocols, also related to wearable data collection or using an Apple Watch, also protocols to deal with the psychological emergencies, also protocols and simulations about how to deal with the accidents. And then protocols for occupancy and entertainment. We are imagining some parties, some celebration days like the national days or international days like Christmas sometimes or the days celebrated in Earth. Also body games, yoga, physical exercise, reading. And then the third, also we are considering protocols for food microproduction in the vertical garden. And then this means that we need to have a protocol for cultivation, protocol for maintenance, protocol to collect the food, protocol for rotation and disposal of the plants in the end of the lifetime, also best time for irrigation, male-female pollination, also plant cycle and plant lifespan. And then also each facility in the station operating Mars, each specific facility presents a 3D printer. Okay, in the first photo, it's possible to see a 3D printer using clay to print ceramics. Okay, and this would be interesting to print like something like bowls or some like forks or plates. Okay, in this case, the 3D printer in the main station will be used to print this kind of material. And then we also have some ideas about the protocols for 3D printing. In this case, we need to have CAD projects to be CAD projects to be used in the to be printing the projects. Also, a protocol for product degradation, the recycling protocol, like crushing the discarded items, preparation of pallet, also preparation of filament for 3D printing, also the process of additive manufacturing process. Okay, and then now I'm going to the final part of my presentations related to spin-offs, some technologies applied to Earth. Also, yeah, imagine that what we are doing in terms of the 3D printing will be also shared to Earth. Also, some guidelines to be applied to daily lives in Earth are related to mental well-being, daily routines, health occupancy, also health environmental safety guideline. Okay, and then the last part of my presentation is these some impacts of for sustainable development goals. And then we imagine that what we are doing in the main station can bring some ideas uh, about health, about quality education, about also gender equality, because we would like to have the women participate in this crew. Also, it's related to the clean water, because you need to save water, also save energy. Okay. Also, is related to recycling, because you need to recycling mainly the package generated in the discarded in the cuisine, okay, in the kitchen. Also, is related to management, the goal 16, and also to partnerships, okay, because we are dealing with many international space stations, okay. And then this is my contact if someone would like to contact me. Okay, thanks so much for your attention.